All right, cool. Um, so my name is Pete George. I'm in Denver, Colorado. I'm a senior manager for data science, machine learning operations, and artificial intelligence at Lumen Technologies. So uh, I wanted to this presentation might be a little bit more exoteric for than other users you may have seen as um, part of this conference. I wanted to kind of just see um, really kind of show where we are. There's the basically the um, we're in terms of where we are. A little bit about me. So a little bit about me. Um, I've been in data science for some time. Very passionate about greyhound rescue, dog rescue. If you see little guy behind me, she's really cute. So I wanted to kind of just uh, give, give you guys an agenda here. There's data science is something that's really interesting in my mind. I think that there's uh, how do we best enable data science and success through data science specifically. So I'm going to talk through three different kind of approaches here. I'll leave some time for Q&A. I'm going to watch the chat for every few minutes, and we can kind of see if you have any questions. Feel free to drop them in the chat, and we'll kick off. So um, COVID essentially caused a lot of firms globally to really rethink their business model, the value proposition, their employee empowerment, how they were doing, what they were doing, what was successful. It really defined everything in the whole business landscape. Uh, and what happens, especially with data science, is that put everybody in a very unique position. Um, the theme of this conference essentially is that it's no longer data science is no longer the shiny object in the room. I think that's valid. It's become much more widely accepted. But in my experience over the past 10, 20 years, I've seen companies struggle with kind of implementation of just process control. Um, and really kind of these drivers that really affect data science, the success of data science, the success of data science practitioners, and everything of the like. Uh, I'm not saying that without these things, data science can't be implemented effectively. Um, but if I were to just give my 2 cents, these would be my recommendations. So if we kind of look at top-down success over the past 10, 15 years, I've seen leaders say, okay, they want data literacy, machine learning, deep learning, AI. They want the data to tell them what they should do. Um, I think this is very interesting in my mind, because I think we're kind of setting ourselves up for failure at that point. Um, putting too much emphasis um, on what they know and what they don't know. The problem with this kind of approach is that you are limited by what you know, and you're limited by what you understand, what kind of things you've seen in the past. There's the Chinese philosopher Lao Tzu. There was a He once said, "When I let go of what I am, I become what I might be." I think that's the crux of where we really need to be in terms of data science, in terms of a really in terms of really enable success. Um, so what should the leaders be asking? So how can we turn business problems into data problems? How can we use these tools, use the people, use their user expertise? How can we best determine the requirements to build analytical solutions? Yes, there are tools out there. There's R, there's Python, there's Scala, Julia, C++, all that fun stuff. I'm not concerned about the tools. I'm concerned about how can we solve business problems today. How can we leverage the data that we have, the data that we don't have? Can we go after these more these kind of learning what we don't know? That's going to kind of be a theme where uh, about where I'm going to kind of come back to is we really need to understand um, where we are, and then kind of empower others to learn, empower others to grow and to do everything, and to really kind of be successful all together. Because at the end of the day, we're all in the same boat. We're all going for it. We have to lean on each other. So how do we kind of opening the door there? How do we um, how do we focus and enable each other to succeed? How do we how do we open our minds to change our own trajectory from a data perspective, from a process perspective? How do we break down those obstacles to get us there? How do we what data are available to really get us there? So it comes with individual contributors. So Aristotle once said, or maybe twice, the whole is greater than the sum of its parts. So, in order for a team or a group of teams or team of teams or whatever to be successful, they have to work together. It's not just 10 people or 100 people or 1,000 people working individually. We have to work together. So how do we best enable that? We've some of you may have seen this before. I cannot coin this. I cannot take credit for this. This is something that I've seen in numerous PowerPoints. 10 things that require zero talent. These are really kind of the soft skills. Treat people with respect. Treat people with others, and really try to be an agent for effective change, respectful change, passionate. Be kind of that high energy performer that really can be successful. Kind of along those lines, when I'm interviewing for people, when I'm traveling and talking to students in across the globe, and trying to impart some level of my knowledge, and really try to understand, so that they can be successful in their life. The three things that I look for in an interview, are really things that I try to impart on others, to really be successful. First one is 100% drive. It's very necessary to be hungry to improve, have a thirst for knowledge, really try to know where to go. It's not necessarily, hey, I know this library in Python, I know this library in R, I know this how to do this thing in Scala, Julia, whatever it is. It's really, no one's really going to know those answers, all of them. So how do we go about learning? How do we go about learning when there isn't a framework in place? Communication, in addition to that, is essential. How do we break down those communication barriers and really be successful altogether? And then likewise, organization. If you're working on one thing, you are very lucky. If you have one task, you're very lucky. In my experience, and going back, that's not the. You could have a plate with 10 things on it, have to be organized, have to be really flexible, agile, and be able to pivot as necessary. So we've kind of jumping into communication here, kind of breaking down those communication barriers, because as we start adding nodes, as we start adding people, the communication paths that the communication can travel goes exponentially. So how do we effectively break that? How do we effectively communicate and be effective as individual contributors, as a piece of the pie, as a piece of the team to a whole? Let's see. So likewise, so as we've covered the individual contributors, we've covered leadership. Now kind of going into kind of that middle tier, that middle management aspect. So those of you who are familiar with process control, William Edward Deming, basically an American that basically led the movement for in Japan for quality measurement and manufacturing processes over after World War II. He was not recognized in the U.S. until late 1970s, but is seen now as the father of quality. So it's my first position out of my undergraduate career was I'm a manufacturing engineer for Johnson & Johnson. It was a very eye-opening experience to basically understand that there is this quality system out there. And what's interesting in my mind is that this quality system doesn't have to be applied to manufacturing. It could be applied to going through an airport. It could be applied to a whole bunch of different other things, to sales, to marketing, to data science. How do we best effectively create and enable a total quality management system from the ground up, where the quality is really implemented from that ground level. If you want to kind of explore this a little more, you can look up the 14 points for management to be successful. Essentially, it basically takes the stance for total quality management and the PDCA cycle, which is essentially the scientific method, to then test these things together, and really kind of institute quality control at that entire level. So at the system level, kind of, and yes. So in addition to that, he also kind of published the 7 deadly diseases of management, which are basically barriers that prohibit management from improving the effectiveness of their teams. So things like lack of consistency for planning, which thus emphasizes the presence of short-term thinking, and thus can lead to fire drills, and shifting priorities frequently, and things of that nature. So the second major piece, the PDCA wheel, also known as the Deming cycle, Deming wheel, where we have plan, do, check, and act. Essentially, this is the kind of that scientific method. We have a hypothesis, we want to test it, ready to go. As part of Deming's work, we have a number of things coming out of this, kind of lean engineering and Six Sigma, both of which can be applied very, very well to data science. Lean engineering, essentially, a macro level view, where you basically try to map out the entire process. If you have say you have a database, you have a data table, you have a CSV, you have something, you want to essentially run this model against it, get some output. That value stream map is going to be very, very simple. If you have different processes that are all interconnected, you have logic gates saying, okay, well, if I get this output and then this output, what happens? Having that macro level view where you can identify those individual bottlenecks, those individual. So if I have this grand app and I remove the bottleneck here, what will happen? What benefit can I see? And then we have the ability to literally test those, and that's where Six Sigma comes in, where we try to quantify and rein in our variation, the process variation. So as part of that, we have hypothesis testing, we have success criteria, we have a feedback loop where we have the ability to really kind of use all this, use our knowledge, use our process knowledge, um, and really try to really get to the crux of what is causing that variation. And that could be data drift. That could be model drift. That could be over time the data are changing in a specific um, place, specific area, a specific table. If a table gets rewritten, what happens? How do we implement process control at that level that we don't have, and subsequently and then monitoring so that we get notified when something goes haywire. Um, and then implementing that process control, but not necessarily at the data science, maybe machine learning operations level, but further in all areas of the business. I found that's having that kind of that view, that two-tier view of that map at that macro level, and then we hone in and we do like our deep dives into different nodes inside that map. It can be very beneficial. About success in all of that. So ideally, we want to maximize throughput with sacrificing our own quality. So if we basically push more data through a pipeline, does that fail? Do we get errors? Do we get something happening where there's not necessarily something good? We're losing more than we're gaining at that time. So feel free to the QR code essentially is linked to my LinkedIn. Feel free to snap with your phone, snap up with your mobile device. Send me a message. Happy to help out however I can. I'm going to close this out. Does anyone have any questions? Cool. Feel free to take a snap of that with your mobile device. I appreciate everybody's time, and hope you have a great day, evening, wherever you are. Thank you.